Okay, so here's a weird one. You've got this one word, derivative, but it lives in two completely different worlds. I mean, to a mathematician, it's this fundamental thing in calculus, but then you talk to someone in finance, and suddenly it's this high stakes tool of immense power and, well, risk. So, how on earth did a single word come to define both pure math and global finance? We're going to dig into that.
All right, let's just lay it out side by side. On one hand, in calculus, a derivative is just this really precise tool for measuring change. Simple enough. But on the other hand, you've got the legendary investor Warren Buffett calling financial derivatives weapons of mass destruction. So, a clean, simple measurement tool and a weapon. How can both of those things be true at the same time?
And that right there, that's the puzzle we're going to try and solve. What's the hidden link? What's the thread that connects these two powerful and, let's be honest, totally opposite sounding ideas? To figure it out, we've got to go back to the beginning, back to the source.
So, our first stop is the world of calculus. This is where it all began. And here, a derivative is all about one thing, the math of change.
You know, the core idea here is actually pretty simple, but it's also incredibly powerful. A derivative in math, it tells you the exact speed of something at one single frozen moment in time. The best way to think about it, it's like your car's speedometer. When you glance down, that number you see, that's the derivative. It's not your average speed for the whole trip, right? It's your speed right now, this very instant.
And this is where it gets really cool, because it's not just some abstract math concept. It's super practical. So imagine you've got to build a pipeline from an oil rig way out in the ocean to a refinery on the coast. You've got choices, right? You could run it straight to the shore and then build along the land. Or maybe a direct diagonal path is better. Well, using derivatives, you can actually calculate the rate of change in cost for every single possible path to find the one that's the absolute cheapest. It's basically a tool for finding the perfect solution. And the thing is, this isn't just guesswork or trial and error. As you can see, finding a derivative in math is a really structured, logical process. You follow the steps. It's this reliable, repeatable procedure for finding that hidden, instantaneous rate of change. Doesn't matter if you're solving a problem in a textbook or optimizing a real-world pipeline. Okay, so here's the key takeaway, and it's hiding in plain sight, right there in the name. A mathematical derivative is a new value, that rate of change we've been talking about, that is completely 100% derived from something else, from an original source. In this case, that source is a function or an equation. Now, I want you to really hold on to that idea. Something's value is derived from a source.
All right, with that idea locked in, let's cross the bridge. We're leaving the world of calculus and stepping into the world of finance. And you'll see we're making a little switch here, from deriving a rate to deriving value.
So, if we're talking about deriving value, what's the source in finance? Well, it's not a math equation. It's something called an underlying asset. And this can be, well, almost anything that has a value that changes. We're talking about a share of Apple stock, the price of a barrel of oil, the exchange rate between the dollar and the yen, even something as abstract as an interest rate. This is our new foundation. And bam, here it is. This is the connection. A financial derivative is, at its heart, just a contract. It's an agreement between two parties. But, and this is the absolute key, the contract itself has no real value on its own. It's just paper, right? Its value is entirely, completely derived from how that underlying asset performs in the future. See the link? Okay, so why bother creating these weird contracts in the first place? It really boils down to two main reasons, and they're kind of like the two faces of a coin. We've got hedging, and we've got speculating. This breaks it down so well. So, on one side, you've got hedging. Think about a wheat farmer. She's got her crop in the ground, but she's worried that by the time she harvests, the price of wheat might totally tank. So what does she do? She uses a derivative contract to lock in a good selling price today for the wheat she's going to harvest months from now. She's basically buying insurance, reducing her risk. Now, on the other side, you've got speculating. Some trader sitting in a high-rise in Chicago can use the exact same kind of contract to just bet on which way the price of wheat is going to go. He's never going to see or touch a single grain of wheat. He's just taking on risk, pure and simple, hoping to make a buck. And the sheer variety of these things is just mind-boggling. You've got options, futures, swaps. It's a whole financial toolbox. And you can build these contracts around pretty much any asset you can possibly think of. Stocks, interest rates, currencies, commodities like oil and wheat. And it's this incredible flexibility that's let the derivatives market explode to the size it is today. And when I say massive, I mean a scale that is genuinely hard to wrap your head around. And that, of course, brings us to the risk.
Just look at that number, $700 trillion. That's the estimated notional value of just the private over-the-counter derivatives market. Now, let's be super clear. That's not actual money being traded. It's the total value of all the stuff, the stocks, the bonds, the oil, that all these contracts are based on. To put that into perspective, that number is about 10 times the size of the entire world's economy, the whole planet's output for a year, times 10. It's staggering.
So why is a market this gigantic so darn risky? Well, it comes down to a few big things. First, there's leverage. This means you can control a huge amount of an asset with just a tiny bit of your own money. It's great when you're right, but it absolutely crushes you when you're wrong. It magnifies everything. Then there's counterparty risk. A lot of these deals are just a promise between two parties. But what if the other person, the counterparty, goes broke? Well, their promise is worthless, and you get nothing. And finally, there's this scary thing called hidden tail risk. That's when something totally unexpected happens, like a global crisis, and a bet you thought was super safe suddenly blows up in your face. And that brings us right back to the beginning, doesn't it? When you start to see how all these huge invisible risks are all connected, you finally get what Warren Buffett meant: financial weapons of mass destruction. He wasn't just being dramatic for a good soundbite. He saw how this stuff could seriously threaten the entire global financial system. Okay, let's pull all these threads together. We've jumped between two completely different worlds, right? Calculus and high finance. But it turns out they're both built on the exact same core principle. And that central idea is this: whether you're in a math class or on a trading floor, a derivative is not the thing itself. It's a brand new value that gets its existence from something else. In calculus, it's the rate of change derived from a function. In finance, it's the value of a contract derived from an underlying asset. In both cases, it's a really powerful tool for understanding how things depend on each other. So that really just leaves us with one final thought, doesn't it? A derivative, whether we're talking math or money, is ultimately just a tool. And any tool can be used in different ways. You can use it to figure out the most efficient way to build a pipeline. You can use it to help a farmer sleep at night knowing their crop is safe. Or you can use it to place a bet so massive it puts the entire global economy at risk. The tool itself is neutral. The real question, the one that really matters, is about us. How do we choose to use it?